Assalamualaikum warahmatullahi wabarakatuh. Saya Syazwan Ismail daripada LKKM Sungai Buloh, staf Kementerian Kesihatan. Pada pagi ini saya akan share dengan you all tentang bagaimana cara kita nak membuat apa yang dipanggil sebagai peralatan saintifik bagi tujuan urban health analytics. Urban health analytics ni, kalau tuan-tuan puan fikirkan apa yang telah dipelajari, if you want me to speak in Malay or English? Malay. You prefer in Malay? Rojak also can lah, mix also can. English, I prefer English actually because my Malay are not very fluent lah. Alright, so first of all, there is urban analytics, urban analytics terminology nowadays. They are talking about the big data analytics, how the data being integrated from one perspective into another perspective, and then all this urbanized is already been happening quite some time as compared to the rural area. So if you go back and see, there are a lot of urban areas that are being developed rapidly as compared to the rural area. Dan kalau anda tengok dekat dalam urban ni, ada banyak challenges lah. Salah satu challenges yang ada, the primary challenges that may face by the occupant ataupun orang penduduk dekat dalam urban ni tak lain tak bukan adalah compactness ataupun high density. So dalam episode density ni high, ada juga banyak threat lah ataupun ancaman kepada perkara demikian. Antaranya adalah yang melibatkan tentang sustainability of the environment, especially with regard to the air pollution. Air pollution ni akan datang daripada mana? Majority of it coming from poor transportation management lah, and then the traffic flow being congested here and there. Yang saya cakap ni adalah dekat negara kita sendiri lah ya. Alright, so without further ado, let us discuss more on our objective. So our objective is basically we want to develop tools that are not I want to say affordable tools that are able to collect scientific data and also insightful information with regard to our community and also urban areas. And then we are going to use those information to make a decision. So that is the primary aim of our duty today. So we are trying to develop something like this, and then we are transform something like this into the information. So we are trying to send the data to the clouds, and then based on the data that we receive in the clouds, we are going to make some interpretation and also a decision-making process. So, before I go further, let me discuss with you about the components that you have, and then after that, we are go one by one. Okay, can you do that? Okay, so the first one is actually the PMS 7003. So this is the PMS. PMS is actually a particulate matter sensor ataupun particle terampai. Particle measurement sensor ni adalah jenis plant tower, brand dia plant tower. Anda boleh buka, anda boleh tengok, and then they have also the cable. So the cable is already being modified in such a way that you can straight away use it lah, and then interface with your MCU ataupun dipanggil sebagai microcontroller unit. Okay, any question? Okay, function. The main function for this sensor is actually to record and also capture the ambient, indoor or outdoor with regard to the particle matter. It's either 0.3, 0.3, 1.0, 2.5, and also particulate matter 10 micron. So all that can be captured using this sensor. So this sensor is quite affordable. You can buy it online. You can also use it in your future project and also dekat you punya setup lah. Kalau you all kerja dekat PBT kan. Ada yang kerja PBT tak kat sini? Tak ada So majority of you is coming from different background lah. Kebanyakannya saintis, makmal ataupun orang fieldwork. Semua ada, yang duduk dalam lab ada, luar lab ada, atas lab ada, tepi lab ada, semua ada lah kan. Alright, so alat ni adalah seperti mana yang anda pernah tengok, namanya dust track. So dust track is a commercial product developed by TSI. So the price is quite high lah, but this one is quite affordable. If you go and visit to the IoT product nowadays, they are using this kind of sensor to collect the data and then make some sort of calibration with the algorithm and so on, and then they are going to interpret in terms of whatever applications that you want lah. Okay, ini yang pertama, PMS, particle sensor. Tujuan dia adalah untuk monitor dust and also particle matter. Kita akan nampak nanti macam mana nak gunakan. Alright, so yang the next one is the IR sensor. IR sensor ni dari satu color yang warna hitam, satu lagi yang color lucina. Ini adalah contoh dipanggil sebagai infrared sensor. It's a very simple sensor. So this sensor is actually will be used. This sensor, yes, you can open that one also because we are going to interface it after this. Yes, you can open it. But remember, when you open it, make sure that for those, especially women lah, wearing the satin kind of clothing to be aware because you will generate the electrostatic. So the electrostatic coming from your hand is actually can damaging those chip. Just to let you know lah, that is the idea lah. If you go into the electronic kind of world, that kind of things are being discussed rigorously lah among the electronic enthusiasts. So kalau anda ni orang biasa-biasa, hantam sajalah labu tak ada hal pun. Okay, so this is the infrared sensor. So what is the function? It's basically to detect any changes with regard to the infrared position. Ini infrared maksud dia ada satu sensor kat sini yang akan transmit the data, transmit the infrared wave, and then another one is the infrared receiver. So whatever that is being blocked here is going to be identified as a switch lah. It's an invisible switch, if you can imagine that one. So why this one is very important? If you can imagine during the COVID-19, people want to use something to do with the untouchable sensor to activate the switch, or to activate the pump, or to clean your hand and something like that. Automatic dispenser. So they are using something like this. It's a very cheap sensor. It costs around RM1 something like. This one is very cheap. Okay, and then another one is the MQ135. Okay, this is the sensor. This is the air quality sensor. If you can open any box, there are two different kind of sensor. The first one is MQ135. You can see over there, 135. 135 is actually a multiple sensor. It is meant for measuring smoke, carbon dioxide, and also many part of the pollutants that can be configured and also calibrated according to the sensor. It's very cheap sensor. This is electrochemical sensor. Okay? If you want to know more about all these sensor, you can find out in a lot of literature that are already available, even in the scientific community. For example, if you type 135, MQ135 is one of the air quality sensors that are available for you to be used. You can just type there, MQ135 datasheet. So this is the way that you want to find some information with regard to your sensor. Kalau anda nak tahu sensor anda di mana, so anda boleh download lah daripada data-data yang telah diberikan lah oleh developer ataupun manufacturer. Ini dia punya standard lah. Anda boleh download datasheet yang berkenaan. Ya, dia boleh detect carbon dioxide, dia boleh detect smoke, dia boleh detect macam-macam lah. Kalau tanya saya untuk makluman tuan-tuan dan perempuan, actually the limitless is more on your calibration. You need to calibrate according to a specific coefficient, regression equation, and then from there you can translate it into a much more information, useful information lah. Nanti anda akan tengok lah macam mana nak buat. Cuma saya tak akan cerita dia punya analytics behind lah ya. Saya akan bagi anda kod yang dah siap. Tapi kalau tuan-tuan dan perempuan berminat nak tahu lebih lanjut, nanti saya akan bincangkan kemudian. Yes, puan. Satu lagi is MQ9 tak salah. Bukan? Kalau you all ke sama? Oh, dia ada tulis. Dekat situ. Dia ada label MQ9 and MQ135. So the difference is MQ135 is basically we'll be using it for detecting the smoke or the carbon dioxide lah. MQ9 is usually being used to monitor the carbon monoxide. MQ9. Dekat tepi tu dia ada tulis lah MQ berapa tu. Okay, 135 ni biasanya kita panggil macam normal gas sensor. Kalau anda dekat rumah nak tengok LPG, anda akan gunakan MQ2 ataupun MQ4. That one is for LPG, liquefied petroleum gas. Nak detect any leakages ke whatsoever, boleh beli. Pakai ni, yes. You can use this one and then connect with the MCU, microcontroller, something like this. And then you are able to send the information lah with regard to the status of the indoor, whether there is an increase or decrease of the toxic gases. Macam yang saya bagi kepada tuan-tuan puan ni is smoke dan juga CO2 serta CO. Sebab MQ9 is for CO. Okay, itu adalah sensor yang ketiga. Kemudian kita ada sensor-sensor yang lain seperti kalau anda tengok yang dekat dalam breadboard. Okay, sebelum saya terlupa, apa yang anda dapat dalam package ini termasuk breadboard. Okay, anda boleh buka sekarang breadboard. Breadboard ini adalah yang color putih tu. Color putih. Saya beli yang color putih ni supaya yang buta warna ni boleh nampak lah. Tak adalah maknanya senang untuk saya explain. Okay, this is the breadboard. To understand the breadboard is actually a way to connect the wire or any module into your electronic prototype. It's a very robust process because you need to engage it and then disengage it before you solder everything on the board. So I took one example. Ini contoh. Saya ada satu wire. So let's say I want to connect this wire with this wire. Saya tunjukkan satu contoh lah. I have this wire the red wire, I want to connect with the ni kalau anda tengok, sekejap saya zoom. Okay, anda boleh tengok kat depan So saya ada satu wire warna merah kan. Okay, and then I have another wire which is the what is this? Purple color. So how to connect from this side into this side, this wire to this wire? I can solder it. That is one way. And then another one is actually convert it or attach it into your breadboard. Ini dipanggil solderless breadboard. You can just attach it like this, and then you can connect in any row. Each of the row is connected to each other. So that means if I connect something like this, these red wire are going to transmit the electron from the positive or negative into the purple wire. Same also goes to your sensor lah. If you got a sensor like this, may I borrow your sensor one? Okay, for example, I got a sensor like this. Okay, I may attach my sensor on the breadboard, and then if I want to connect it, I can just use this one lah. For example, this one is the red color. I'm going to attach it on the VCC. So the VCC on the top right over there. So that is the connections. That means the wire from this red color are already connected to the VCC on the sensor. That is the way that you want to connect something lah in terms of using the breadboard. Any question? Itu cara nak guna breadboard. Okay, on your breadboard there are some sensors also that I also give to you. The first one is the BMP sensor. If you can borrow me that one. Okay, this one is the BMP sensor. This one is the I2C sensor. BMP stands for the Bosch sensor. It is meant for measuring the temperature, altitude, and also pressure. Okay, this one. Alright, so another one, which is the TEMT 6000. TEMT 6000 is the light meter, light meter, or we call it as a light sensor. This 3-wire electronic module is actually meant for measuring the intensity of the light. If you do not have any lux meter, you can also use this one to collect the light level. And then the next one is the MAX 4466. MAX 4466. This is the basically a microphone that can be calibrated and used as the sound level meter. So whatever that I share with you and give it to you is actually open for business. Means that whatever that you want, sky is the limit lah. You can do whatever that you want lah. But of course, my focus, I will share with you the main of the air pollution lah. Because my field of expertise, of course, on the air pollution itself. But of course, you can also leverage all this idea to try to collect another environmental issues such as air, physical or water lah. Okay, ada tak apa-apa soalan sebelum saya pergi dengan lebih detail lagi with regard to the sensor? Ada Okay, so sensor semua dah bagi kan? Alright. So, the next one that I'm going to share with you is the output. From the module that you have, you also have this one. We call it as the OLED. OLED is stand for organic liquid electronic display lah. So this one is OLED display. Same like whatever that you have on your smartphone lah. This one is OLED display. It costs around less than 7 ringgit. The main functions of this thing is actually to give some display to you lah, so that you know whatever that you connect, whatever that the reading is being shown is already indicated over here. Faham tak? Dia macam display, tahu display? Yes, betul. OLED lagi mahal. Okay, sebenarnya OLED ni, yang ini harga dia adalah sebab dia organic base. Organic means that there are some organic material inside the compositions of how they build it lah. So yang ini adalah jenis OLED. Ada lagi satu yang kita panggil sebagai LCD biasa. I think that is a very good question. Contoh kalau anda tengok LCD 1602, this is the LCD. Yang apa kawan kita cakap ni tadi adalah betul. This is the example of the LCD. The things that I share with you and I bought it for you is actually the OLED display. So the difference is, beside the size, is the current consumption. This one is much more current hunger as compared to this one. So that's why I'm using this one lah. Okay, so any question else? Okay, that one is output. Therefore, in any prototyping, we have the input and output. So if you can imagine, all the sensor, we can consider all this as the input. Means that they are trying to give you some information with regard to the sensing technology that they have based on the sensor and so on. And then we have the output. Output, this is the example of the output where we try to display. Or you can also show the indicator using the LED. But I did not give you any LED, right? But if you want, you can also purchase by yourself or you can ask me later on. But this is the most basic one that enable you to do some prototyping with regard to the environmental health technology. Okay, any question? Okay, if you do not have any questions, then I may continue with the PMS. The PMS is actually have the laser inside. So we have many idea and also many methods in terms of how to detect and also determine the environmental pollutants. One of it is using the laser light scattering imaging. If you learn before in the environmental health course, for example, you learn about the technology called as the light scattering image. Light scattering image purposefully using the laser and also the mathematical equation by the MIE equation. Is a very complex equation to translate the depositions of the chemical, which is specified under the particulate matter equations, and then based on the scattering image and the reflectant by the laser, then the particulate can be estimated. Itu adalah contoh penggunaan laser. Ini panggil laser light scattering image. So kalau tuan-tuan dan perempuan beli yang komersial pun sebenarnya mahal-mahal saja je. Ada setiap benda bila saya, because you still can make some calibration and also some relative comparison with regard to those values. Faham Contoh nanti kalau kita tengok sekejap lagi, kita pasang alat ni, kita cuba hidupkan lighter ke ataupun kita cuba tiup, kita tengok ada tak changes of the reading. So that is the main idea of our discussion today. Kita nak try to collect the insightful reading and also translate it into the decision making process. So that means if the level is high, then we need to do some action. When the particulate is high, that means there are so many things happening in the ground. When there is some increase of the particulate matter 2.5, for example, that means somebody inside the room is smoking, and therefore they are not fast. They tak puasa. Contoh. Yes, this one is very sensitive. You can even detect the 2.5 micron when the smoker come near to the sensor. That means they are already exposed themselves to the particulate matter sizes 2.5 micron. Inside these devices, they have the small fan over here. You can see. So the small fan is actually can become an active sampling process. So this one is active sampling. Other than that is actually a passive one. Okay. So now let us begin to another one, which is the additional. This one is called SD card module. If you can see over here, we got the SD card module. It's a very small one. This SD card module also is quite affordable. You can buy it online, less than 2 ringgit. So you can use any SD card as you wish. So the smaller one is, if I'm not mistaken, available in the marketplace nowadays is 8 GB, right? So 8 GB, if you collect the data for about 1 second or I think 1 minute lah, you can collect the data almost many centuries lah. Maknanya sangat-sangat lama lah anda boleh buat data collection tu berpuluh tahun. Sebab data yang saya pernah collect untuk 6 bulan pun baru 1 megabyte. Kalau 32 gig mungkin sampai puan pension pun data masih lagi di collect lah. So that is the beauty of the using the SD card. Okay, another one is the RTC. This one is RTC. RTC, when I said RTC, that means is a real-time clock. Why we use the RTC? RTC is basically have the what we call it as the crystal oscillator. You can see something somewhere around here. We have the crystal oscillator. So the main functions of the RTC is actually to remember what is the current date and time, because we want to make as a data logger. So today I'm going to give you some idea how to create a data logger, and then how to store those information inside the SD card, and then later on we can analyze it straight away in our computer. So it's very benefit process. I got two important idea here. The first one, we collect the data and then we store it inside the SD card, and then we are going to also send the data into the cloud using the Wi-Fi connectivity. So we have also the ability to use the Bluetooth, but I think I reserve that one for any further discussion later on. Okay, this is the example of the what is this? It's a modem kan, Wi-Fi hotspot. The example of bringing this item to you is actually to share the idea how you want to collect it autonomously or in open area. Let's say you want to collect in a nearby area, you do not have some internet connectivity because you do not want to leave your handphone behind. Therefore, you need something like this, less than 50 ringgit. And then you can install it, or you can just take other people's Wi-Fi lah, which is I share with you the way to obtain it ethically. I do not want to teach you either. Alright, so ladies and gentlemen, so this is the primary idea. We want to use the RTC to create a data logger, and then we want to collect the data and then store it inside the SD card, and then we have the sensor that are going to collect almost a lot of futuristic environmental condition. And then last but not least, I want to introduce to you is the MCU, or we call it as the microprocessing unit. So this is the name as the ESP32, ESP32. Okay, there are many MCU. If you type inside the internet, MCU, microcontroller unit, controller unit. Saya salah sebut Nama? MCU, Manchester United Club. Okay, there are many MCU available nowadays. You must differentiate it according to the use of it lah. So the first one is MCU. MCU stands for microcontroller unit. The main purpose of the microcontroller unit is actually to control a very simple task with a simple logic. That means, okay, you know about this, collect it, the data, store it inside the SD card, and so on and so forth. This module, less than 20 ringgit, is quite robust, where you can connect anything into the internet, and also you can use it to connect it to the Bluetooth. That means you can put anything on the pin over here, the open pin. We have the mail header. So all this mail header, you can attach it with something such as our sensor, and then after that we can enable the data collection, and then you can retrieve those information and then send it into the clouds, or you want to store it inside the SD card, or you want to send it to your computer. I took one example. Sometimes we got the data from the electronic devices that we have in our commercial kan? We buy the commercial one, we got the sensor, but that commercial devices is not directly connect to the something that can record, that can make as a dataloger. So actually you can hack it by using something like this. We call it as the MCU, microcontroller unit. So we have also named as a microcomputer. Microcomputer ni contoh macam Raspberry Pi. Pernah dengar? Tak pernah dengar? Saya tunjuklah contoh Raspberry Pi. Raspberry Pi ni adalah microcomputer. Microcomputer ni dia besar alat ni juga, but maybe longer a little bit. It's also a computer. It's small enough that can run simple OS such as Linux and so on, that you can configure it to become a server. Tahu server? Server ni macam server yang you pasang dekat rack yang besar tu lah. Tapi ni server yang kecil, just running conditions, very small functions. Itu kita boleh buat. Itu dipanggil sebagai Raspberry Pi. Contoh lah, saya tunjuk lah. Raspberry Pi Zero. Raspberry Pi Zero ni is the common one lah, but it's very hard and difficult to buy nowadays. This one. Dia taklah zaman dulu sangat. Dia kira dalam 2016, 2017 lah. Tapi ni kalau cari kat mana-mana, kat Malaysia pun, dekat overseas pun dah tak jual lah. Ataupun it's very limited. Because scavenger like myself like to buy it a lot. Because it's very high demand. Very high demand, but less production. Very little production in the world. In the world. So there are some issues with regard to the Raspberry Pi production, for your information lah. Alright. So let us go into the details. So this is the ESP32, the board that we are going to use, and then we have another one to make your life easier and also my life easier to explain it to you, which is the adapter. Okay, this is the adapter. So the functions of the adapter is nothing more than make your life much more easier to connect each of the sensor to the adapter. Okay, so you can refer to the adapter. So this adapter is actually meant for 30 pin. The ESP32 consists of 30 pin. Dia ada 30 pin. So 30 pin tu kita akan pasang lah. But make sure you did not install it wrongly lah. The position should be like this. This is how we want to install it. And then after you install it, then you can put some wire over here and there. And then after that you finish everything. Then you can put some code inside. And voila, you are ready to fly lah. That means your unit is ready to go. So I'm going to explain to you one by one how to connect it, how to use it after this. Sekarang ni saya nak terangkan je dulu barang-barang ni, supaya anda semua nampak lah apa yang telah anda bayar tu adalah berbaloi ataupun tidak. Macam ni? Rakam apa? Boleh. Nak rakam pun boleh. Sebab tu saya rakamkan siap-siap. Sebab tu apa yang saya buat ni, I try my best to record everything that I said to you, so that you can go back and then make some revision lah. But if you still not clear whatever that I share with you, you can try to drink the zam-zam water and also eat some kismis lah, so that Allah SWT give you some hidayah. Ini student saya faham lah ayat tu. Okay, this is the barrel jack. Ini namanya barrel jack. So the idea of giving this one and then give the hint to Dr. Farah just now before this, because to enable you to use it in a remote area lah, where you can use the 9-volt battery. Okay, so that's why we have the barrel jack over here. Thank you, Mrs. Zahid. And then we have also giving you the adapter. So the box, the white color box is actually the adapter. The adapter for converting the 240 volt into the 5 volts. So for example, if you want to put your device near a restaurant and something like that, and then that restaurant have the Wi-Fi, you have the permissions to get the Wi-Fi, and then you can borrow the plug point, and then you can directly plug it into your adapter, and then you can collect the data for 24/7. So the idea is basically you create a module, and then you try to collect the data. How long is it? How long it can take lah. Biasanya kalau student saya cadang at least 1 week to 1 month. So you all kalau boleh paling sikit you buatlah data collection tu dalam 1 ke 2 minggu untuk dapat representative data, and then based on that data I'm going to share with you how to create a dashboard and also how to analyze it using a simple forecasting technique. And if you can digest more knowledge that I share with you, then I can teach you more on the machine learning and also artificial intelligence with regard to the data lah, to make a certain decision making process. It's quite advanced. Mungkin tapi tak dapat PhD lah ya, dapat master juga lah So nak cerita, you can use this idea to develop much more robust idea in the future. Okay, ada apa soalan tak before kita nak mulakan yang pertama?